In the previous video of the chapter complex numbers, we have seen introduction of complex numbers. In that video, we have seen that what is a complex number, what is the sum of two complex number, difference of two complex number, what are the conjugates of a complex number, what are the modulus of a complex numbers. So we have already discussed so many things under introduction of complex number. Here we have to see some properties, important properties of addition of complex numbers. Okay, so as we have discussed in the previous video, the numbers in the form of a plus ib are known as complex numbers. Okay, this is denoted by z, and a is called real part of z. Here a is real part of z and b is imaginary part of z. We have already discussed all these things in the previous video, so please go through that video so that we could understand well here. Okay, now we are discussing properties of addition of complex numbers. So first property we are going to discuss, which is closure property. This property, closure property of complex numbers for addition of complex number, tells that sum of two complex numbers is always a complex number. This is called closure property. Sum of two complex number is always a complex number. So suppose let z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2, then z1 plus z2, which is equal to a1 plus a2 plus I, b1 plus b2, is also a complex number. Is also a complex number. This property is known as closure property. Now second, commutative law for addition of two complex numbers. Here commutative law of sum of complex numbers tells that if z1 and z2 are two complex numbers, then z1 plus z2 is equal to z2 plus z1. z1 plus z2 and z2 plus z1 both are equal. Means order of these two complex numbers doesn't matter. Okay, so z1 plus z2 is always equal to z2 plus z1, which is known as commutative law. Next, associative law. If z1, z2 and z3 are three complex numbers, then z1 plus z2 in a bracket plus z3 is equal to z1 plus z2 plus z3 in a bracket. So you know the purpose of these brackets. z1 plus z2 is bracket, means first of all we will get the sum of z1 plus z2, then we add z3 here, and here first we get sum of z2 plus z3, then we add z1 with this. Okay, so this is known as associative law. Next, existence of additive identity. Zero is called additive identity. Okay. Here it means 0 plus complex number z, or z plus 0 is nothing but z. Correct? So what is the meaning of 0? 0 is a complex number. 0 plus I0 means here real part as well as imaginary part, both are equal for a complex number, that is 0. So 0 is, in fact, this is a real number, but you must know that all real numbers are complex numbers. Set of real numbers is a subset of complex numbers. So we should not confuse that 0 is a real number but we are calling 0 as a complex number. So there is no scope of confusion here. Fine. So 0 is called additive identity. Next, existence of additive inverse. For all complex numbers, z, that is a plus ib, there exists a complex number minus z, which will be equal to minus of a plus I into minus of b, which is called additive inverse of z, which is called additive inverse of z. Here you will see that if minus z is additive inverse, then sum of a complex number z plus its additive inverse is always additive identity. Okay, this is a very basic rule which takes place here when we add a complex number with its additive inverse, we get additive identity. So these are some very simple, very basic rules for addition of complex numbers. Hope you have enjoyed it. And in the next video, we will discuss about product of complex numbers and rules for the product of complex numbers. So remain in touch with these videos and share these videos with your friends also. Wish you all the best.